Now we are going to discuss about velocity potential, phi. A velocity potential is a scalar potential used in potential flow theory. It was introduced by Joseph Louis Lagrange in 1788. It is denoted as phi. The basic idea to calculate the phi is by multiplying the velocity with the distance traveled by the fluid. So to get the velocity here, we could calculate it by phi, or the potential velocity, divided by the distance traveled by the fluid. So to write phi here, you could write like this. You could draw an oval here and you cross like this. It can be a little bit round like this and so on. So please make sure that you write carefully, because we have phi and we have psi here in our calculation later on. So this is phi and this is psi. So now we are going to write an equation for phi for Cartesian coordinates. What you need to do is you need to draw a diagram like this. So this is an x-axis and this is the y-axis. So we have a rectangular element here. So the width here is dy and the length here is dx. So this is the velocity in x direction, and this is the component velocity for the y direction. So to calculate the phi, please remember the idea of this one. Velocity is equal to phi divided by the distance traveled by the fluid. So here, for u here, we could get relationship between u and phi is phi divided by the distance traveled by the fluid. So means if the velocity is moved from left to right, so the distance traveled by the fluid in this element is dx. So we write u is equal to d phi over dx, because we are focusing on a very small element here. So we use the idea of differential method here. So u is equal to d phi over dx, and v here, it's moving from bottom to the top along the y direction here. So we could write v is equal to d phi divide dy, which is the dy here is the distance traveled by the fluid in this element. So for potential fluid, it already mentioned previously, it is a scale or a scalar, so it does not have any direction of negative and positive. So mean both terms here is remain in positive terms. So this is the coordinate, this is the polar coordinates, and we are going to derive the relationship between ur and u theta with phi. So I hope you could draw this one. It is quite similar with the continuity equation and also with the circulation. So we have ur here parallel with the radial, and this is the tangential velocity, or the velocity regarding to the angle here. So and then we could have relationship ur equal d phi divided by dr, because dr here is the distance traveled by this element, and u theta here is equal to d phi over r d theta, because r d theta here is the distance traveled by this fluid element. So again, because potential velocity is a scalar, so it doesn't have any negative or positive, so we could get both term here is in positive terms.